So here we're talking about finding the slope. And the other class, when I said find the slope, they're like, you can see their faces. Some of them are like blank. I have no idea what you're talking about. And some are like ready to go. And some of them are like they're lost, so I don't even know where they're going. But do you guys remember that we talked about the change in y over the change in x? Do you guys remember that yesterday? What is this little symbol right here called? Delta. Good. And what does that mean? What does delta mean? That's where it came from. Change in. You could say change in this case, y. So what would the denominator be? Change. Oops. That's how much I wanted to write it. A change in x. So again, we looked at that yesterday. Okay, but I have two other equal signs here on the right side, and then I have another one over here. There's a lot of things that this equals. So change in y over change in x. Change in y. Think of the y-axis. What's the y-axis? Can you guys kind of like picture it for me? Yeah, good. You guys are doing this, right? What axis is that? It's the vertical axis. So we say change in y refers to the vertical change. Vertical change. And I hope that makes sense, because if we're talking about the y coordinates, we're talking about vertical coordinates.
Wouldn't that be the y2 minus y1 x1?
Would it be? Yes, it will be. Yeah, we'll talk about that. Good. So you remember that from either yesterday or last year, because we did talk about that. So what are we talking about? Change in x. What kind of change is that? Horizontal. Yep, that's a horizontal axis. Okay, so we get that, I hope. So we got the vertical change over the horizontal change. There's another way of putting vertical change and horizontal change. It's a non-mathematical way. It's a little bit easier for us to remember. Let me see if I can refresh some of your minds. Rise over run. Rise over run. When you think of rise, normally don't you think of like a vertical ascension? And then run, that's a little bit less clear, but run is talking about a horizontal change. So when I say vertical change, I mean rise. When I say horizontal change, I mean run. When I say change in y, I mean rise. When I say change in x, I mean run. Okay, that's a lot to take in. But Caroline, you actually alluded to something. When I hear the word change or the phrase change in or change, this is the operation I think of usually with math. I think of which operation out of the four main ones? Division. Okay, you think division? Multiplication maybe? What's that second one that we're using for? It's actually subtraction. Subtraction. What was the change in temperature, right? So you're looking for what was the difference in temperature. So if it was cold this morning and it got warmer this afternoon, you're trying to find, all right, what's the change in temperature? How do you figure that out? You subtract. So change refers to subtraction. And we'll get to that later on in this lesson. What's this all talking about, though? What is the change in y over the change in x? It's the slope, which is designated with what letter? M. You guys remember slope is m? Okay. All right, so that's that's actually multiple parts to an equation, but they're all equal to each other. Okay. Let's go to some examples here. The reason why we talk about rise over run is because it's easy to picture that. So go ahead and draw yourself a coordinate plane. Give yourself some space between tick marks, because each tick mark is going to be worth 2. 2, yes, please do that. The reason it's worth 2 is because in your book it's going to be worth 2, and I don't want you to be like, whoa, Mr. A, what are they doing? They're just making it worth 2 or 1, but they only show me every other number or whatever. You've got to get used to seeing it in different ways. So give yourself space. Don't cram in the ticks all together, because you won't be able to see your work. In fact, I think I'm going to change mine, because I'll kind of emphasize what I'm saying here. So you keep doing it. I'm just going to change the way I put it on my board. So it doesn't have to be huge tick marks, but like something more significant. Okay, so what's each tick mark worth? 2. And you don't have to label all of them as long as you know that they're all 2 and you use them as that. But especially when you first do it, it's nice to label because we tend to forget sometimes. Okay, this is what I want you to do after you get your coordinate plane set up. I want you to put these points on your graph. So when you're ready, I'll get to that. Okay, I think you guys are good. All right, the first point I want you to put is 0, 1. 0, 1. So here, starting at the origin, do you go left or right any? Nope, but you do go up 1, which is half a tick mark, but it's like right here, between 0 and 2. That's your first point. Your next point is going to be, we'll go with 3, 3. 3, 3. So here I'll go 3 to the right, and I go 3 up. And I should.
Done odds.
You could have done odds, yeah, but again, they're going to give you just like this. You're going to be like, all right, how do I interpret it? And you know what's cool about these problems? You're not going to have to draw these out, by the way. You're not doing that. They're going to give that to you, and then you interpret it, which is nice. And then let's go with one last point. -3, -1. -3, -1. So -3, -1. And what do you think you should do with those 3 points? Yeah, connect them, please, with a line. Yay. Okay, so you should have something like that. Again, you get this on your homework. You get that. They give you all that. Okay, what did I say the slope was equal to? It's equal to the change in y over the change in x, or the vertical change over the horizontal change, or the change in, like I wrote out, change in y, change in x. What did I put at the very end of that? Rise over run. So we're talking about rise over the run. Okay, how do you find the slope in this problem? Does anyone maybe remember? There are a lot of, I like the ideas I got last time. John?
So what I'd do is I'd so first I'd find the rise, because it says rise over run.
Yeah, how do you find a rise?
And I'd see how many times it goes upward.
From where?
From one of the points, you can do any of them.
I'll go from...
Easiest from like the middle or the left, so then you also make a new point.
Okay.
And so I'd start at the middle one, because that seems the easiest for me.
Just start like here.
Up 1 to -2, and then up 1 to -3 until I'm horizontal with like the other dot. So then I'd say the rise would be -3. See how many times I go to the right, and I'd go, or right to the right, I'd say -3.
That's okay.
And then I'd see how many times I go to the right, and I'd go 3 times to the right. So I'd say the run is 3. So I'd go, the rise over the run is 2 over 3.
Okay, so I got your explanation. That's solid right there. So how are we going to do it together? This is what you do. Pick a point. Okay, and you're like, which one? Any point is fine. Good point about picking these 2 points normally. But can someone tell me what the coordinates are here? Because I'm going to show you something later. It was -3, -1, right? Okay, what's this point? 0, 1. And then this last point we put, or I get 3, 3. Yep, 3, 3. Okay, so we have the ordered pairs there, so we have some numbers to deal with. Okay, I'm going to pick this point, and I'm going to see, all right, how do I go from this point on the line to this point on the line, okay? So here, do I have a rise? Like, did I go up or down? I do. So how far did I go up to go from here to here? How far did I go up? 1, 2, right? I took 2 jumps. Is that positive or negative? It's positive. I went up. Okay, so the rise is 2. Now I have to ask, did I go left or right? I went to the right, which is a positive number. How many times? 1, 2, 3, right? Because remember, these are all worth 2s. I went to the right I went to the right 3 times. So what's my run? 3. So you know what my slope is? 2 over 3. Ma'am? Sir?
What if you had them like straight across the line? Like you had the dots like on -4 and then one on 0, 0. just like straight on the line.
So here and here?
Yeah.
Okay, we're actually going to get to that. Like, what happens if you have that kind of line? And what happens if you're on that? Which happens? Yep, we'll look at that. Okay, how about this, John? We picked this one, right? I think it was this point, -3, 1, somewhere right here. But what if I pick this point and this point? Will it work? Okay, let me see here. How far did I go up to get to this point? 1, 2,
3.
was it 3? Yeah. I'm sorry. Yeah, I think I'm marked. Oh, I see. No, I got it. 1, 2. Yeah, my drawing's not perfect. So what's my rise? 2. Okay, from here, how much did I go to the right this time? 1, 2, 3. Okay, good. So I got 3. What'd I get? Same thing, right? Okay, but Mr. A, I noticed that you keep picking the left point and then picking a point to the right. But what if you picked a point? What if you picked a point on the right and went left? What's going to happen? The cool thing about slope is that it always works, no matter what 2 points you pick. Okay, I'm going to go from here to here. So how much should I go down? 1, 2. Okay? That's -2, isn't it? That's -2. All right, how far did I go to the left? 1, 2, 3. That's -3. Oh, man. Oops. Wait. What's a negative divided by a negative? So what do I get? Positive 2/3. So does it matter which 2 points I pick? It does not matter as long as you get the correct rise, get the correct run with the correct sign. If you're not picking the right sign, you're going to mess it up. Mr. A, are you sure about this? You said all this stuff and I don't believe it. Okay, I want to pick this point and this point. I'm going to go from here to here. How far did I go down from here to here? 1, 2. Sorry, I know it's kind of off. 3, I think.
It's 4. It's because you're at
1, 2, 3, 4. Yeah, my diagram got all messed up. Okay, so I went 4, right? From here, 3 to -1 would be 4 spots. So what do we say? -4. Okay, how far did I go to the left again? 1, 2, 3, 4, 5, 6. Okay, and it's negative, right? Oh, that's totally different. What do I get? What, positive or negative? Positive 2/3. Same thing, right? Does it matter what 2 points you pick? Does it matter which order you use? No.
well, no.
Yeah, and it seems like it would, but actually it always comes out to that 2/3 if I do the right signs, right? That's negative, or I could go positive, which nicely works out that way. Okay, let's go to another one here. So draw yourself another graph, and we're going to go through some exceptions because there are some of these. Okay, let me give you this graph. Each one's worth 2 again. 2, 4, 6. And really, I only need one of those. Okay, what kind of graph is this? Horizontal line. Yep, horizontal line. Why? Because it goes left to right. Okay, so it goes on positive 2, goes through that on the y-axis. And I'll give you some time to draw it out. Okay, Alyssa, can you give me 1 point on my line? Just give me one of the points.
2.
Oh, sorry, ordered pair, like something.
0.
Yeah, right here, that's 0, 2. Right here, 0, up 2. Can someone give me another point? Just one other point, doesn't matter, because they all have to work. Caroline?
1, 3.
1, 3 would be right here. That's okay.
So you meant like give any.
Yeah, on the line, yep. Murphy?
4, 1, 2. Sorry.
Okay, 4, 2, right here. So that's 4, 2. Okay. And it doesn't matter which point you pick, which points you pick, they should work. Okay, somebody tell me what is the rise from those 2 points. Let's go from this point to that point. How far did I go up or down? 0, right? Okay. What was my run? 1, 2, 3, 4, right? What's that worth? 0. You draw this out? Did you write this right here?
Yeah. Oh, no, I didn't
Yeah.
write the...
That's
I wrote
okay.
the graph, just not the-
Okay. Does it matter which points I picked? No. Jensen, give me another point. And then over here somewhere. Anything. That's on the line. -3, 2 right here. -3, 2. Okay, let's use these 2 points. From here to here, what's the rise?
0.
It's 0 again. What's the run from here to here? 1, 2, 3, 4, 5, 6, 7. What do I get? 0. Same thing, right? Same slope? That's weird. Why does it always come out to 0 in this case or 2/3 in the other? I think it was 2/3 in the other one. Why?
Because if you have, like, if you, let's go with the easy one. So if you have, like, parts of the pizza, and you have, like, 0 sevens, you have no pieces of the pizza. It doesn't matter how many you have on the bottom. No matter what, you have 0 pieces.
Yeah, you have the same pizza, let's say just a small pizza. You cut it into sevens, you get 0 out of them. You're not getting anything, right? If you cut it into, fourths, ooh, you're getting 0/4, so this time. Not getting anything, right? So it's the same value, 0/4 and 0/7, same value, no matter how you cut it up. Okay, for a horizontal line, you know what your slope is always going to be, by the way? It's always going to be 0. Always, always, always. Once you look at that line, 0 slope, boom, got it. You're done. Okay, what would be the other type of line? What's the other special type of line? No, we don't have to draw it. We're just going to actually talk about it. Vertical line, right? What's the slope there?
No slope.
What do you mean by no slope?
Meaning it doesn't slope.
All right, there are 4 types of slopes you need to know. So draw these out. They're just sketches. So you just draw this out on your paper. Here's your coordinate plane. The first type is if you have a line that from left to right, always read it like a book, from left to right is going upward. What kind of slope is that? Positive slope, always. Remember that 2/3 one? From left to right, which way was it going? Up. It has to have a positive slope. So you're like, what do you mean by that? That means that your rise over your run should always come out to be positive something. Okay, the other type of graph, the main type of graph, is if you have a line that from left to right is going downward. What kind of slope is that? It's negative slope. So no matter what point you pick, you need to have a negative answer, because if not, well, I'll just tell you this. If it goes left to right down, it's not possible for it to be a positive slope. Impossible for positive slope. The other two are those exceptions. If you have a horizontal line, what's your slope? Horizontal line is going to give you a 0 slope. Sorry, I had to write so low. 0 slope. And then what if you have a vertical line? Yeah, we're going to call it something different, and you guys are going to, well, not different, but haven't used this as much. It's an undefined slope. Undefined slope. You're like, what does that mean? What do you think undefined means? I cannot define it. So that's why it's so hard. I don't know how to explain it to you.
But isn't undefined still defining it in a way?
You can say yes. I get what you said. Yep, it is. Saying undefined is somewhat of a definition. But what's the difference between a 0 slope and an undefined slope when you're working it out?
So like the 0 slope has 0 over it.
Okay, 0 over any number.
And then the undefined one has 0 at the bottom, and you can't multiply probably like you can't reverse that and multiply it because it's 4.
Yeah, nothing is going to do that. Yep, so that's how you get that undefined. Basically, it's this. You put in your calculator 4 over 0, you know what you're going to get? Error. And some calculators will say undefined. So you're like, what does that mean? It means I don't know how to define it, other than undefined, which, yes, is true. You're defining it.
So for the line,
Mhm.
zero slope, even if it's in the positive, it's still zero.
Yeah, like if I just drew another one, that's another horizontal line, it's still a zero slope. Whether it's in that region or not. Same thing over there. And even these, it doesn't matter as long as left to right goes down, negative. Left to right goes up, positive. Always. Ma'am?
So like now that you have two lines in the zero slope, would you?
Oh.
This is probably like a stupid question, but would you call it like parallel?
Ooh. Whoa. Okay. I'm tutoring geometry students. They're going over that. What do two lines with the same slope, how are they defined? They're always going to be parallel. So if they're both zero slope, parallel. If they're both undefined slope, parallel. If they have the same slope, no matter what the numbers are, they're going to be parallel, always. Yeah, that's parallel lines. That's geometry right there. Okay, I think we're good with this. We don't need that. Go ahead and I think I had them look at in their workbooks. So go to your workbooks, please. And don't close your textbooks. We're going to go back to that real quick. But in your workbooks, the soft cover book, go to page 109. And I want you guys to do number 6. So they already drew the graph for you. You don't have to draw the graph. Just find the slope. Remember what was for bonus? Yeah, now I'm making you do it for real. So on number 6, get me the slope. And if you got it last time, it's probably like 2. It's worth 2 points. Okay. Yeah, so on number 6, on page 109, find the slope. So you find the rise over the run and hopefully simplify it. No, because they gave it to you in the book. You can just use your book. So you guys see the graph for number 6. They gave you a graph. And then you just have to find what's that rise over the run. You can write in your book too, which is nice. And I think I sketched it out here. Yeah, this is it. Take down 0, 0. This point right here was 1, 2. And the last point I put was 2, 4. 2, 4. Okay, so those are this is just a sketch of the graph they gave to you. Okay, how many of you have an answer? I'm not saying you have the right one, you just have one. You have a slope, m equals blah. Question? Or you have the answer. Okay. All right, this is what I'm going to do. How many of you use these 2 points? How many of you use these 2 points? Okay. How many of you use these 2 points? Okay. Did anyone use these 2 points? These 2 right here? Okay. Oh, just to check? Yeah, that's great because then you can confirm it or prove it. Okay. I'll do these 2 points. I know a lot of you did this, but I want to make sure. From here to here, what was the rise? What was the rise? 2. It was 2. So that rise, so the slope so far, 2. What was the run? 1. 1. What's the slope? You could say 2. You just say the slope is 2. Positive or negative? Is that possible? From left to right, what does that graph do? It goes up. Does it go as, does this one go as steep as that one? No, but do they both go up from left to right? Yeah. And based on their steepness, that's going to change your numbers. That's how the numbers change with 2 and whatever that one was. Ma'am?
On my homework, I forgot that it mattered if you did rise first or run first. So I got 1/2.
1/2, yeah. So on the bonus, don't worry about it. You didn't get anything marked off. But from here on out, what do you always put on the top of the fraction? Rise. What do you put on the bottom? Run. Always. Don't mix them up. I'm going to see if you guys remember that in just a moment. Yes, sir.
So if you put 2 over 1 on the homework, would it still be correct?
Yeah. I'll give that. Because it is rise over run. But always simplify it if possible. Okay.
I don't know if it's like this or not, but when you go from 0, 0 to 4, you do a rise over run.
Let's see here. So from here to here to, from here to here? Okay, what's the rise? 1, 2, 3, 4. Okay, so we get rise of... Okay, so you get 4 over 2. You agree with that? 4 over 2 is 2 over 1, which is just 2. Like, that's okay. Yep, so we confirm it, and that's good. I'm glad we tested it out because it should work, I hope. Okay, you guys okay with that? How many of you can find it if I gave you a graph? You could just, count the tick marks, okay? But what happens if we didn't give you a graph? Is there another way to possibly find it? You can, one option is if I gave you 2 ordered pairs. You can go ahead and you could do a table, you could do you can do an actual graph, you could do a circle mapping technique. There are a lot of things, but there's got to be an easy way to do it every single time. There's a formula.
It's the y2
No, y equals mx plus b.
I'm going to give you guys a different problem from the last group. Can someone give me an ordered pair from the last graph I just had that we just worked on? Give me one ordered pair. Sorry? Was 0, 0 on there? Yeah. All right, 0, 0. And then don't give me 1, 2 because I use it for the other one. Give me the other one. 2, 4. Okay, 2, 4. Okay. If I gave you a problem that said something like this, I want you to find the slope of a line that crosses through these 2 points. What would you have to do? You could draw your ordered pair. You can get your coordinate plane, get your ordered pairs, put the line, then see what the rise or the run is. But again, there's a better way to do it. Remember, it's always change in y over change in x, right? And what does change in y refer to? The rise. And what does the change in x refer to? The run. Okay, rise over run. What did I say? What operation did I say change in refers to? Subtraction. So I hope some of you remember this. Y sub 2 minus y sub 1 over, what do you think the other part is? X sub 2 minus x sub 1. Now I'm so happy we talked about sub 1, sub 2 before. Remember we talked about subscripts? So here's the reason why we use subscripts in this problem. Look at my ordered pairs. Do you guys remember domain and range and x and y values? You remember all that? How many x's are up here? There are 2 x values. How many y values up here? If I didn't use subscripts, would it be super clear which one I'm referring to? No, you might switch them up. The other person might not switch them up. What is switching up? I don't even know which one it should be. Now we have an order. Okay, so this is what you do. Does anyone know which one's y sub 2, y sub 1, x sub 2, x sub 1? I don't even know which ones are which. But can I give you a hint? And then I'll get you two to help me out. Which one has to be x? The first one. The first one has to be x. Which one has to be y, therefore? Okay, so now we're deciding which one's x sub 1, x sub 2, which one's x sub y sub 1, y sub 2. Which one's x sub 1?
X sub 1 is 0.
What's x sub 2?
0.
X sub 2.
Oh. 2.
2, right? Because remember, these 2 are the x's. I know that, and that can be tricky. Sarah, which one's which one's y sub 2?
4.
4. Which one's y sub 1?
0.
Okay, so you got to put them in an order pair, and they have to match. Like x sub 1, y sub 1, x sub 2, y sub 2. Does that make sense where we get x's and y's? Like x and y, x and y. And then first, second. Ma'am?
If you have more than 2 ordered pairs, could you use this?
Yeah. You could decide this. I got a third one here. You're gonna like, I want to use these 2, or I want to use those 2, or I want to use those 2. You just pick 2. Yeah. And thank you for saying it doesn't matter. You girls said these are the x1, y sub 1, x sub 2, y sub 2. You know what's cool about this problem? They could have been switched. As long as you keep the 1s together and the 2s together, this problem works every time. But let's see if it works. The first time. What's y sub 2 up here, Nick? What should be y sub 2? 4. And minus, right? It's always something minus something else. So what's y sub 1? Anybody? 0. All right, so you got to put 4 minus 0. What is x sub 2? 2. What's x sub 1? Minus 0. All right, what's 4 minus 0? 4. What's 2 minus 0? Wait, what do you do with that? Simplify it, and what do you get? 2. Wait, is this what we got on that first time working this problem out? So can you do it with the graph? Yes. Can you do it with the ordered pairs? Yes. Can you switch around if you wanted to? If you really wanted to, I want a graph. I really need a graph. Then do it. Mister, I hate the graph. Can you just do it with the numbers? Yeah, you can do either way. Which one do you think is better? Why is a formula better? Okay, I like the graph, by the way. I like it personally. Like, oh, just count. Especially when they do it for me because it's easy to count. But why is this way better? Mackenzie?
It's less time consuming than drawing out a graph. And it's like a little easier to learn. And like once you have it memorized, it's memorized.
Okay, yeah, you can memorize it. It's quicker.
If you have like really big numbers.
Oh, yeah. Like if I had the ordered pair 201 and 157. You could graph that, but it's really tough to do accurately. So why don't I just use the formula? What other numbers might be harder to graph? Okay, yeah, thousands. What type of numbers? Fractions, decimals. Is it possible to graph fractions, decimals? Of course, but it's harder to do. This can give it to you accurately. Any questions on this? How many of you, before I went over this right here, you didn't remember it? Like you totally forgot it. Was not in your memory bank. Okay? How many of you, now that I put it, you're like, oh yeah, I get it. Okay? You know what happened there? For most of you, except for Wyatt, all of you heard this before. We went over this last year. But after a year, it has to come back to you. Can I give you a little confession of a math teacher here? Okay, if I taught Algebra 2 5 years in a row, and I haven't taught it for 3 years now, if they told me next week, Mr. A, you're going to teach Algebra 2, you know what I have to do? I have to take my book out and start reviewing. I have to start, yeah, that's right. That's what we do here. Oh, yeah. Yep. Am I going to know all of Algebra 2 right now after 3 years being off? No, I will not, because there are some things where we look at it in Algebra 1, but now we want to look at it different. Okay, yeah, got it. But it takes a little bit of
Thinking.
Okay, thinking, time, practice, review. Like just review, which is practice time, and they all go together. Imagine that. Okay, you guys ready for yours? I need you to do on page 119 in your textbook. So that's why I wanted your textbook so open. I want you to do number 4. It says find the slope of the line that contains the given point. So it's kind of like this problem. Number 4 at the very bottom of page 119. Now, you have everyone in here, 18 of you, 15 of you need to get it correct. If all 15 of you get it correct, we're done with the lesson. If 14 or fewer get it right, I'm going to give you another problem. So go ahead. Number 4 on the bottom of page 119. Find the slope. You can do it any way you want, but just find that slope. Once you get your answer, raise your hand. You get one try to get it right. So don't just keep giving me all these answers. You're just going to get one. Oh yeah, no pressure. I forgot to say that. Okay, if you're done, raise your hand. I'm coming to check it. Oh, so, yeah, I can't answer a question. I'm sorry. Okay, I'm coming around now. I'll just say yay, nay. No. No. Yes, sorry. Sorry, you did not get it correct. Where is it? Leave it as a fraction. And that's a mixed number, so leave it improper fraction, you're good. Yep, 1.
Leave it improper?
Yeah, leave it improper.
Do you simplify it?
As much as you can, yeah. 2.
Wait, simplify? Wait.
So for example, can I give you an example of what I want? If you got 10 over 2, to reduce it, you'd get 5 over 1, but you should write it as 5, because that's the easiest way to see it. But if you got 20 over 6, for example, 20 over 6, you should write 10 over 3, and you can leave it 10 over 3 because it doesn't change the whole number. So, okay, I think I have 2. Okay, 3. Yes, simplify, yeah. Yeah, so, yeah, that one. So 4. It's a little off here, one of these. 5. Is that your answer? 6. 7. Sorry, where's the answer? It's a little off. It's a little off. 8. 9. 10. Oh, 5 more. Remember, one chance. 11, I think. 12. 3 more. That's all I need. 3 more.
Wait, but I thought this, yeah, okay, but you wrote it wrong. You're going to write
Oh. The most common error from this class and last class on this problem was that you said it's the change in x over the change in y. Is that it? No, it's always got to be change in y over change in x. So it has to be that order. So some of you flipped it. I think we polled everyone, or I don't think we'll have enough, but the answer is 3 over 2. 3 over 2. So, yeah, but I think we had too many myths that wouldn't have...
Mr. Ray, I did the formula the right way.
Awesome.
I still got it wrong, and I just thought I knew it was wrong because it's not right. So I did the graph. So can we check the formula?
Yeah. Okay. How about this? Give me the order pairs real quick.
3, 5, and -1.
Okay. Now most of you just did this is x sub 1, y sub 1, x sub 2, y sub 2. Is that correct? I'm guessing most of you did that, and that's fine. Just do it in that order. Okay. What's y sub 2? -1 minus y sub 1. So what's -1 minus 5? -6. All right, what's x sub 2? -1. What's minus 3? What's -4? Wow. Yes. -4.
So I just did state change opposite.
Yeah, you can do it that way. And what's negative over negative? Positive. So most of you had a positive. And then you get 3 over 2. So you see how that worked?
Yeah.
Did you do it that way? Like those?
I did what I accidentally did. I did x sub 1 and x sub 2 on the top two.
Oh, yeah. That's okay. Hey, listen. That common mistake was to flip these around, and then some people just put these both as x1, x2. But remember, the first number is the only one that could be x. Second one's the only one that could be y. So then you can adjust. All right, number 6. Number 6. Same page, 119, number 6 at the very bottom. Find me that slope. And 15 of you, again, must get it correct in order to move on. Use the formula, do the math, write the numbers down, write that negative sign, see if it's adding or if it's subtracting, depending on the numbers given. Oh my. Negatives. When you're done, go ahead and raise your hand. One try. Simplify it as much as you can, but don't write them as mixed numbers. You can leave them as improper fractions if they would change to a mixed number, or a whole number, integer. Okay, I'm coming around, hopefully to give some numbers. Sorry. Okay. 1. And don't share answers because we want to be fair here, and I want to see if you guys are doing well. That's a little off. There's one number off. 1. We're still at 1. A little off. Oh, yeah. 2. Yeah, it is. But 3.
What did I do wrong?
I'm not sure. I kind of just glanced through it. I'm not sure what happened there. A little off. Man, these are off just by a little. 4. Reduce. It can be reduced. 4, 5, 6.
I know I got it wrong.
Mm-hmm.
Is it because I should keep the denominator? Should I keep it 2 instead of 2? Is that what I did?
Oh, it's 0 minus negative 2. 6. So close. 7. I did. It's close.
It's negative. Let's try that.
It got closer, I think. Okay, 2 more here. Oh my. I threw this negative one because did I check yours already? But okay. 8. 9.
Wait, can you just? I meant to write this.
Oh, gotcha. Oh, 10. I don't think we're gonna make it.
Because I think I got it.
No, let's just do it here real quick. Okay. Ooh. Yes, it's negative, and really the answer should be negative 4. So if you put negative 4 in 1, I gave it to you, but it's negative 4.
Wait, can I get it too?
Okay, give me the ordered pairs.
Negative 2 and 6, and 0 and 2.
Okay, most of you said x sub 1, y sub 1, x sub 2.
Negative 2. For the 0.
All right, what's y sub 2?
Negative 2.
Negative. Most of you said negative 2. Did you have to say that one's y sub 2 is negative 2? No, but okay. Minus 6. What's that? Negative 8. Okay, what's x sub 2? 0. Minus negative 2. Minus negative 2, which is really just plus 2. That's what I was saying, Sarah? 0 minus negative 2. Mm-hmm. And then that's negative 4. Ma'am?
I divided I went like this, divided by 8, because it can go into 8, which that is 1, and then...
Oh, yeah, but technically 2 divided by 8 is 1/4.
Yeah, 1/4, that's what I thought.
Yeah, but then you have a fraction 1 over 1/4, technically, and that changes to negative 4. So don't divide both numbers, but like 8 doesn't go into 2. 8 does go into 8, right? But 8 doesn't go into 2. 2 goes into 8. It's like the reverse. All right, last one here. Oh my. Okay, I have to do it. Number 5. 15 of you. Be careful, guys. The head work isn't working here. Wait. Yeah, take your time. No pressure. Wait, there's a little pressure.
Be quiet.
So we're doing number 5. Please show subtraction. Don't try to do it in your head because those signs get mixed up easily. So it's y sub 2 minus whatever y sub 1 is. X sub 2 minus whatever x sub 1 is. And it has to be, there has to be subtraction. Okay, in celebration of the day after Halloween or the 1st of November, if 6 of you get it, you can leave. 6. Okay. Just, I'll say, what is it? Okay. 1, 2, 3, 4, 5. One more. How does it simplify?
I want to right. It's right. No.
6, 7, 8, 9, 10. Okay. Go, guys. We'll go over this tomorrow. 0, 0.
Don't we have 2 maths? No, we don't. We don't have any homework? We don't have any homework today.
Leave before I change my mind. Alyssa, good job. And even when I was talking to John, you were saying you were giving me good feedback, I think. Yes. Yeah, and we'll go over it today.